okay? So now we're going to talk about this Anderson fault classification. This is, you say you come from geology, you've probably seen this before, right? I mean, this is very common in geology. And when I first encountered it, I said, well, this is silly. I mean, why do we need to memorize names of things? We're engineers. Essentially what this is going to do is it's going to characterize the relationship of the magnitudes of stress and sort of give them a name. And I kind of thought, well, why do we need to do that? Because I'm an engineer, I know stress, I can compute the stress on a fault. I don't need to give it some name, I can give it numbers, right? But it's so common, it's so ubiquitous, particularly in the geology literature, that a lot of times you'll just read, this was a normal faulting regime without any other information, right? And so because it's so common, it's worth learning so that you understand, oh, a normal faulting regime, S vertical is the maximum, principles is the maximum of the three stresses, right? So again, this is something that you'll just have to memorize. I'll give you a little trick at the end once we cover all three of them. I'll give you a little trick that I use to sort of memorize them, how I remember it. I can guarantee you'll be tested on this because it's so ubiquitous. So in a normal faulting regime, the vertical stress is the maximum. Now remember, in a normal faulting regime, the hanging wall moves down in a direction. Remember I said sort of the way I remember it is in a direction normal to gravity, right? So in the same direction as gravity, the hanging wall moves down. And so the vertical stress being a maximum accommodates that motion, right? You can almost think of the vertical stress being the maximum, so it's pushing the hanging wall down, accommodating that motion, okay? And so then you just order the other two. So the thing you have to really remember is the place of the vertical stress. And if you remember the place of the vertical stress, then you just order the other two, right? SH max is always greater, by definition, than SH min, right? It's in the name, right? It would be weird to have SH min greater than sign SH max, right? So then the reverse faulting is just the opposite, right? So it's so in a reverse faulting regime, the vertical stress is the minimum, right? So the reverse faulting regime, the hanging wall moves up relative to the footwall. And so in this case, the vertical stress needs to be small compared to the other two to accommodate that motion, right? Because essentially the hanging wall is moving in a direction there's some force pushing on it, but it's still, the other two forces must be greater than that to accommodate that motion, to overcome the force pushing on it, right? The vertical stress, the force of gravity. So in the reverse faulting regime, the vertical stress is the smallest, and then you just order the other two, right? And so the last one is the strike-slip faulting regime. And so in this case, the vertical stress is in the middle, and then you order the other two. And the way I have it drawn, I just want to point out that the horizontal stresses are in the plane, but they're not necessarily perpendicular. So these black arrows indicate sort of the relative motion of the fault, but the direction of the principal stress doesn't necessarily need to align with that. So the blue line there is the thing I'm trying to point out here is it's in this same plane. And it could possibly be in a direction parallel to the fault, but it doesn't have to be. Right? That doesn't concern the classification. Okay? So, here's the summary table, and again, the trick that I use to remember this is that if you can just remember this order, like normal, strike, slip, reverse, you can just remember that in your head, normal, strike, slip, reverse. You can sort of recreate this table in your head, and it's relatively easy Because if you remember that normal strike slip reverse, the vertical stress goes on the diagonal, and then you just fill in the blanks. Right? So that's how I sort of, whenever I'm reading a paper and they say normal stress, if I can't immediately recall this, I sort of recreate this table in my head. Right? So that's the Anderson or Andersonian classification scheme. It's ubiquitous in the petroleum engineering literature. You will encounter it in papers and books and other things. Right? And so one thing I will point out is that we're going to go on and we're going to use our engineering knowledge to actually resolve stresses on faults and determine if they're going to slip or not. And while the far-field geologic regime may be normal faulting, you may learn that the fault is actually strike-slip or something like that. So they don't necessarily agree with the overall regime in all cases. And this is pretty common in the Earth, too. I mean, the overall faulting regime that you actually can visually see, right, from satellites or whatever, because that motion evolved over tectonic time, like millions of years. And in more recent history, things may have changed. And you may get some activity, may be due to injection, right? You may be injecting water there. Well, the motion of the tectonic plates is not, you're not going to really change the shape of the continents by injecting water from a small well, right? But you can change the stress on a fault that you may resolve. And it may sort of appear to have a different classification than what the overall tectonic classification is. I don't know if that makes sense. So it's just a point to beware, if I give you a problem in the future and I give you, say, two of the principal stresses and I say it's a normal faulting regime, I'm sort of saying, okay, well then order the other one according to this, and then then solve the problem. And if it doesn't work out where the fault, you're going to actually be able to compute exactly which direction the fault's going to slip. And if it doesn't work out exactly, if I tell you it's a normal faulting regime, and it turns out that the hanging wall is moving parallel to the footwall, don't freak out and think you got the wrong answer. That can happen.